Welcome students, Pushi sir again. Today I am going to discuss combination of cells. Combination of cells. The cells, what is a cell? The cell is a source of energy which pushes the charge in the electrical circuits in which it is connected. Basically, you have a cell, you can send current through the external circuit. Without a cell, you cannot make the current flow in a steady manner. The energy which is produced in the cell is necessarily by a non-conservative force, so that the cell will be able to do a network in a closed loop of charge motion. Okay, that's part we must have studied in this cell. These are my credentials, as you know already, must be knowing me by now. In the cell, we know a particular maximum power transfer theorem. So here, right, we know that the maximum power dissipated by load takes place when the load resistance is equal to the internal resistance of the cell. Let us see what I am showing here. This, okay, this one power I removed, so it's duplicate. Okay, we know that the maximum power delivered by a load takes place when the load resistance is equal to the internal resistance of the cell. This is cell. It has a EMF source and the internal resistance. This total thing I have shown in a dotted boundary, that is this cell. And this EMF source is the maximum energy that cell can produce by that so-called non-conservative force, maybe of chemical origin or maybe mechanical origin, maybe electromagnetic origin. We'll discuss that part later. So the power which will be output through this load will be how much? Current will be E divided by R plus small r. This must be a simple thing for you. And this power will be basically when R is equal to small r. So power will be maximum when R is equal to small r. So P maximum will be I square into R when small r is equal to capital R. So if I write small r in place of capital R, I get E square by 4 small r. That's so now consider a combination of cells. That's the topic, is combination of cells. This black box I have drawn here, there is a lot of cells in there, can be combined any random manner. And this is the load. Load means the resistance through which we obtain our useful power. That is the load. Inside the black box, there may be many cells randomly connected. So how to find the maximum power that can be delivered by the load? I can go on varying the resistance till I get the maximum power. Okay, so let's go to the next page. Let's go to the next page. This is the page 2. So this is the combination of cells, this pushing current through the circuit. This is the load resistance. Okay. So load current is IL, capital IL, that's same as small I only. So if I can replace this combination of so many cells, arbitrary combination of cells, by a single cell and a single internal resistance, which I rename as E equivalent and small r equivalent. But what is the basis of this replacement? Such that the whatever load current is flowing across this load potential difference VA minus VB, we call that VL. Whatever IL is flowing, the same IL should flow. So the same potential difference VA minus VB. If that happens, then I say this single cell, if I can find one cell which can push the same current through the same potential difference as existing, then we say this is the equivalent of this combination. Whatever may be the combination, there may be hundred thousands of cells inside. That's what I wrote here. If we can replace the combination cells by a single equivalent cell, that is EEQ, and an equivalent internal resistance REQ, our problem is over. Okay. How to do this? Let's see the figure 3 and this is figure 4. VA minus VB is the potential across load, that is VL. IL is the current through the load. Now refer to the B4. If the single cell EQ and REQ produces same VL across the load, so that the same IL passes through the load, then the single cell is equivalent of that combination, whatever the arbitrary combination is. That's what I wrote. So in the figure 4, let's come to the figure 4. Travel from VB, and what is this current? IL. So VB are traveling in the current flow direction, like this we are traveling. So we observe potential VB here. Then I see a drop of potential minus IL RQ. Then I see a rise of potential EEQ. Then I am at A. Exactly, that's what I am going to write here. So VB minus IL REQ plus EEQ is VA. So what is VA minus VB then? VA minus VB, which is nothing but VL, V across the load, is EEQ minus IL REQ from this. Okay, so in general, if we can write VL, means V across the load, as C1 one constant minus I through the load into C2, where C1, C2 are two constants. If I can write like this, it's very important. If we can express V across the load in the given combination, in the given situation, whatever VL, if I can write as a constant minus IL another constant, just compare it with this, then the C1 constant is E equivalent and C2 constant will be R equivalent. Very simple logic. I think all of you must have understood till now what I discussed. Yeah, bhai? Are you understanding? Inside that black box, the cells can be connected in series, in parallel, in combination of series and parallel, and fourth one is neither series nor parallel. These are the basic four ways we can connect the cells. Okay, or maybe neither some cells neither series nor parallel, and with them some combination of series and parallel, anything. But basically this type of हम एक सीरीज कनेक्शन का मैं एग्जांपल ले रहा हूँ. देखो तीन सेल है E1 R1 E2 R2 E3 R3, but as you see E1 E2 are connected in a particular manner. In reverse manner E3 has been connected. So this is my load and one dead resistance R1 also there, but this is the resistance through which I am taking my power output. So I'll call this as, let me write this as my power output. I'm taking power output to the load, so this is just a dead resistance. You can consider it another fourth cell which having zero EMF and internal resistance capital R1. You can consider that. Okay, how to replace this by a single cell? Same thing as I told you. Single cell replacing all those three cells. So for that I have to write VL is equal to C1 minus ICL. What is my aim is to write VL C1 minus IL C2. This way I have to express. Let's say what I'm doing. VB minus, this is the load resistance IL, same IL flows through this IL. So VB minus IL R1, and let us see as I go, minus IL R1 minus E3, because I'm going to positive to negative pole of the cell. Again I'm passing through the resistance in the current flow arrow mark direction. So I'll drop of potential minus IL R3, IL R1. I will make it, mistake, I wrote it here as R1 VB, no, sorry, it is correct one. VB minus IL R1 minus E3 minus IL R3, perfect, minus IL R2 plus C2, because minus to plus I am going. Again minus IL R1 plus E1. Where I am VA. So VA minus VB, which is VL, you can check that. This is the VA. This is the AV. VA minus VB is the VL, and this is the IL which is passing here. If you are able to see this. So VA minus VB is VL is E1 plus E2 minus E3 minus IL common R1 plus R2 plus R3 plus capital R1. So now VL is equal to, this is my C1, this is my C2. So I can directly write it here. This is the C1, this is the C2. Yes or no? So what is the equivalent? The C1, that is E1 plus E2 minus E3. What is the R equivalent? C2, that is R1 plus R2 plus R3 plus R1. Here that is minus E3, but regarding the resistance all added. Okay. So this is what I now write. E equivalent, R equivalent, this R. Then when the maximum power output, what I will get? E equivalent square divided by 4 R equivalent, when capital R is equal to small r. Okay. So that E1 minus E plus E2 minus E3 square divided by 4 into small r1 plus small r2 plus small r3 plus capital R. So what is the load here? Load is R. That capital R1 is all now gone to the single equivalent cell. Okay. Suppose R1 is 1 ohm, 2 ohm. So the numerical value if I give here, and this R1 is 3 ohm like this, then you can find those R equivalent in number. E1, E2, E3, if I give, will say 2 volt, 3 volt, this is 1 volt. So 2 plus 3 minus 1, that is 4 volt will be the equivalent. So like this, you can use the numerical values and get the answer. That is very simple. This is how the one of the very easy way to find the maximum power output to the load. This I took as a series. Now going for the parallel combination, we'll go to the next slide, next page. Let's go to the next page. We have come to the next page. It's a big page. Parallel combination. Be careful about parallel combination. As I've drawn 3 cells, 1, 2, 3, they are parallelly connected. 2 are connected in this manner. Their positive pole is facing to the left, but third one positive pole is facing to the right. So this is the combination. This is the combination of the cells. This is my black box basically. How to get the maximum power output to the load. And within black box, that 3 cells connected in parallel. So what should my aim should be? You must be knowing, don't lose sight of our aim. Aim is to write VL is equal to C1 minus IL into C2. This is my aim. Okay. So VL is VA minus VB, and this is load resistance IL. So this is load resistance IL. Then this is also IL. This is I3, I2, I1. So IL is nothing but here I1 plus I2 plus I3. Finally, I don't require either I1 or I2 or I3 because I require only IL. Remember this. So go in the branch, upper branch from B to A, passing to the upper branch. What will say? Will write VB minus I1 R1 plus E1 is VA. So VA minus VB is VL, which is equal to E1 minus I1 R1. Then what is I1? E1 minus VL by R1. Similarly, going through from B to the middle branch and to the point A, going from B to A through the middle branch, what will get? Similar going I2, I'll get E2 minus VL by R2. Just like this equation, VB minus I2 R2 plus E2 is VA. So VA minus VB is VL is E2 minus I2 R2, and this will become I2. Now let us see the third one. The third branch, let us see. That means going from B to A through the lower branch, VB minus I3 R3 minus E3, both are minus because I am going from plus to minus, is VA. So VA minus VB is your VL. So I3 will become what? Minus E3 minus VL by R3. Just rearrange. VA minus VB, take it as VL. Then bring I3 to this side, take this side. So VL minus E3 by R3 is your I3. So this is also done. Okay. Now, as I know, IL is equal to I1 plus I2 plus I3. Just add these three. A, B, C, just add. So it becomes E1 by R1 plus E2 by R2 plus E3 minus E3 by R3. Then minus VL common. 1 by R1 plus 1 by R2 plus 1 by R3. Very nice. So IL is equal to E1 by R1 plus E2 by R2 minus E3 by R3. Had the third cell been connected in similar to E1, E2, then it would have been plus 1. So this is VL minus VL comma, then 1 by R1, 1 by plus 1 by R2 plus 1 by R3. I require which in this manner. I have to bring it to this manner. VL is equal to C1 minus IL C2. Okay, so then to get VL alone, I divide it by 1 by R1 plus 1 by R2 plus 1 by R3 both sides. So it becomes IL into 1 by R1 plus 1 by R2 plus 1 by R3. Then this is E1 by R1 plus E2 by R2 minus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3 minus VL. I want to write in this manner. I am writing it again and again. So in that case, if I write it, this is my C1 and this is my C2. You can check that. Yes or no? You must be very easily understanding this. This is my E equivalent. This is my R equivalent. That's all. This you must be knowing. I'm having a feeling that you must have known it in your classes. That's it. Job is over. An example लेते हैं. This is a single cell. The two branches here. This is my load resistance R. This is some other resistance. This is none of my concern. I want to maximize the power through this R. What should I do? There are two methods. Let's say write, our aim is to write VL. VL means VA minus VH C1 minus IL C2. This is my IL. IL is current to the load. Then the total current, let's say, is I. So this must be I minus IL. That's it. Okay. And finally, together both the currents will make it I. Okay. So VA minus I minus IL into R1 is VB. This I'm sure. Okay. So VA minus VB is your VL is equal to I R1, I small I R1 minus IL R. Okay, fine. No problem. Okay. Now, from in this branch, if I go from B to A, then BB minus small I R plus E is VA. That's my second branch I am writing. So VA minus VB, E minus IR. So VL is equal to E minus IR. So what is small I? E minus VL by R. This is equation 2. And this value of I, if I substitute here, what I get? I am substituting this value of small I in the equation 1. Then VL is I is E minus VL by R into R1 minus IL R1. So VL excited me layout. Then I get VL into bracket 1 plus capital R1 by R is E by small r R1 minus IL R1. Then divide this because I want VL only. VL should be C1 minus IL C2. So divide by 1 plus R1 by small r in both sides. That will give you E R1 by R1 plus R IL R1 small r by R1 plus small. is C1 minus ILC2. So what is C1? E equivalent, E R1 by R1, this R1 plus R. And C2 is small r equivalent. C2 is small r equivalent, that is R1 small r divided by R1 plus small r. That's it. Now you write here this single cell, the R equivalent, and this is my load. All other things have vanished into, or they are replaced by a single cell. Everything across the load I should be able to write as a single cell and single R equivalent. What is the P max now? This E equivalent square, that E capital R1 by R1 plus small r whole square, divided by 4 into small r equivalent. That's it. Then opening the brackets and all this, you get E square R1 divided by 4 R1 plus small r into small. है? That's it. Very simple. अब बोले second method क्या है? Second method is just see, very simple, much simpler than that. This R1, which was connected across R without any EMF source, I write it like this, with 0 EMF and R1 internal resistance. So these two are parallel. So now we can connect the equation of the parallel combination, that equivalent cell of the parallel combination, E by R plus 0 by R1 divided by 1 by R plus 1 by R1. I get this. Is it same as this one? Yes. Yes. Similarly, R equivalent 1 by R plus 1 by ये R है ना बाबू, कभी कि हम लोग गलती से 1 करते हैं. हाँ, ये 1 by R plus 1 by R1. So this is what I got, and this is the same as what we got R equivalent here. है ना? Just see. So same result as we got earlier. Nice. We'll do some other examples later. Now, third one is when there are some cells in series, some cells in parallel. That becomes very easy now. That already we have done the series and parallel. Some cell series combined with some other cells in parallel, what is equivalent, that we can do very easily. But the fourth one, fourth one, when neither series nor parallel, क्या करेंगे? नेक्स्ट बोलते हैं, नेक्स्ट पेज में जाए. पेज 4. ये वेरी केयरफुली देखो इसको. मैं एक एग्जांपल दे रहा हूं. Find the maximum power dissipated in this load R in this combination. There are usually the 5 cells, 10 volt, 20 volt, 30 volt, 40 volt. Their interresistance 1 ohm, 2 ohm, 3 ohm, 4 ohm respectively. And there is a fifth bridge cell that is 50 volt and 5 ohm. 5 cells, just looking like a Houston bridge arrangement. As you know, in a Houston bridge arrangement, no branch is either series or parallel with any other branch. Okay. It looks like a Houston bridge arrangement. But now the question is, for the maximum power that I can obtain from the load, load is a variable resistance. I can go on varying the R so that until I get the maximum power. तो मेरा एम क्या भाई? बताओ अभी तक आपको एम मालूम चल गया होगा. VA, this is point A, this is point B. So VA minus VB is VL. Should be C1, one constant, minus IL, C2. Okay. This is what? My aim is. This is what? My aim is. Okay. no cell is a series of parallel with any other cell. Let's solve it. Going in the lower branch, ये lower branch में जाओ, ये IL है, lower branch में I1 करंट है, तो upper branch में IL minus I1 करंट, then इस इधर I2 जा रहा, तो वो जो ब्रिज ब्रांच में I1 minus I2 करंट जाएगा, तो देन इस ब्रांच में कितना जाएगा, IL minus I2, दोनों को ऐड करो, becomes IL minus I2, है ना। चलो करंट और डिवाइड हम कर दिए यूजिंग किरचॉफ्स लॉ, branch rule or junction rule, you normally say. So now travel from B to A through the lower branch. ये तो आप आराम से कर सकते हो। BB पहले लिखो minus I1R because I am traveling in the current flow direction, plus 10 because going from minus to plus. Yes. Then minus 4I2 plus 40. Yes. That is VA. But I have to write VL na? So VA minus VB is equal to 10 plus 40, 50. VA minus VB is VL is equal to 50 minus I1 minus 4I2. पक्का हो गया ये, कोई एरर नहीं है, ठीक है ना बाबू। और अपर ब्रांच में चलो अभी, B to up through the upper branch come to A. VB minus 2 into IL minus I1 में लिखा कि नहीं देखो, VB minus 2 into IL minus I1, then the battery EMF is 20, R20 plus 20, then again next battery is plus 30, but potential drop in the internal distance is minus 3 IL minus I2 minus 3 IL minus I2 plus 30, where I am VA. Katam. So VA minus VB will be VL, that is equal to 30 plus 20 is 50 plus 2 I1 plus 3 I2 minus 5 IL minus 3 5. ये इक्वेशन नंबर 2 आया। भाई मेरे को I1 I2 को निकाल देने का है, खाली IL रखना और VL रखना। कैसे निकालेंगे, दो इक्वेशन से नहीं निकलेगा ना दोनों, मेरे को प्लेस होल्डर इक्वेशन चाहिए। तो मैं क्या करूंगा, और एक पाथ है भाई इंडिपेंडेंट पाथ, ये क्रॉस पाथ में जाऊंगा, VB one part of the lower branch, then the breeze path, then the another path with upper branch, then I am at B. क्या करूंगा फिर, VB लिखो, VB minus IL into 1, sorry, VB minus I1 into 1 plus 10, अगेन दिखा लेता हूं मैं, VB minus I1 into 1 plus 10, again minus 5 into I1 minus I2 current, लिखा कि नहीं, yes, minus 5 I1 minus I2, then plus 50 volt, then the half of the upper branch, that is minus 3 I1 IL minus I2 plus 30, लिखा कि नहीं, मैं बिल्कुल लिखा, इज इक्वल टू VA, क्रॉस ब्रांच में ऐसा मिला। तो VA माइनस VB इज इक्वल टू 30 50 10 90 minus 6 I1 minus 5 I2, so that is plus 3 I, so plus 8 I2 and minus 3 IL is equal to, that is VL, that is equation number 3. Now I can solve, I can eliminate I1 and I2 and write in terms of IL everything. How to eliminate I1 from equation 1 and 2? Either I1 है, these are 2 plus 2 I1, multiply into 2 into R. So I1 will be eliminated from equation 1 and 2. I did that. Become 3VL is 150 minus 5I2 minus 5IL. Multiply this with, multiply this equation with 2 and R with equation. So 2 minus 2I1 plus 2I1 आ जाएगा. So ये 100 plus 50 150, ये होगा 2VL plus VL 3VL, and this is जो VA minus 8I1 minus 8I2 plus 5 minus 5I2, जो भी मिला मेरे को फोर्थ इक्वेशन क्या मिला, ये 5/2 minus 5I2, ये आप देख सकते हो। एलिमिनेटिंग I1 फ्रॉम 2 to 3 से एलिमिनेट करेंगे, फिर I1 को 2 और 3 से कैसे करेंगे? 2I1 है, 6I1 है, so multiply 3 and add again. So 3VL plus VL is 4VL, 150 plus 90, 240, 4VL plus 240, I1 eliminated, and ये ऐड करने के बाद हो जाएगा 17I2. देख लो थोड़ा सा, 2 and 3, इसमें 3, 9I2 plus 8, 17I2, 15 minus 3, that is 21. देखता हूँ कहाँ चला गया। हाँ, आया 3VL, that is 2 and 3, multiply with 3 and add 3 into 5 plus 3, 18IL आ रहा ना। VL is 19 minus 6I1 plus minus 3IL, and the fourth is minus 5IL. Yes, so 3 multiply इसमें 3 and 2 and 3 से 2 and 3 से कर रहे हैं ना हम लोग, ठीक है। 3 6 and 5, 3 into 5 minus 15, ऐड करो उसको, 3 minus 18, आई थिंक आई मेड ए मिस्टेक हियर, है ना, 18 करना चाहिए था मेरे को, ये 18IL, ठीक। ये क्वेश्चन 5। नाउ I2, this also I don't require, I1, I2 also I don't require, so what should I do? I eliminate this, for between 4 and 5, 17 into 5 is a multiply 17, multiply 5 and add again, then you will get 751, 20, 71, yes, 17 into 17, yes, 20, 17, this is 5, so 17, 5 will be 3750, and how much will be this one? I think 18IL, 1785, and F5, 1785 and a 590, 85, and this will be 90, 85 175 होगा, है ना, this will become 175, this become a 17, 5, 85, 90, 175. My job is over. So this becomes 175 by 71. This is 52.8. This will be something else, 71. कौन बता सकता भाई? What is the division? I think 2.04 नहीं है. It should be something like, let me do that as small calculation first. That is 175 divided by 71. How much? 2.46. तो करेंगे 2.46. 2.46. So this is C2 is 2.46. Okay. So what is the maximum power then? Equivalent square into 4R equivalent. 52.82 whole square divided 4 into 2.46. 2.46. How much? How much is 2.46? That one, 52.82, 52.82 square divided by 4 into 2.46 equal to 283.5. So this is process is no, this point use it 2.46 283, almost 283.5. Okay, so this is what we got. This is not 2 point, this is 2.46. So then this is what I got, the power output P max when R is equal to 2.46 ohm, when the load resistance equal to 2.46 ohm, I get the maximum power output, that is 283.5 watt. Okay, this was a numerical, some I committed a wrong thing here. Okay, while doing calculation here, I made 12 instead of 18. Am I clear? Now it is all right. All right. And this is 175 by 81, 2.46. So that's not a big issue. I earlier made 2.04, 2.46. So 2.46 is your C2, that is R equivalent, and 52.82 is your E equivalent. So the whole thing has been just that whole 5 cells have been single cell 52.82 volt and 52.82 volt and R equal to 2.46 ohm. That's it. So nice. Otherwise, it will be very, very difficult for you. Am I clear? So final conclusion मैंने क्या लिखा बाबू? Using VL is equal to C1 minus IL C2, we can find equal resistance for any combination of cells. Is it okay? So again, thank you all. I am going to take you to the first page itself. So this is the topic which I discussed, the combination of cells. Go to the first page. This is the first page itself. Combination of cells. So this is my credentials, and all of you know. So I think we have come to the conclusion of this lecture. We'll go to some application of this also in next classes. Hold breath. Okay. Well, next time very soon we are going to meet. Thank you all.